Legend means you have a key showing that there's a schist. The name is not important. A marble, a quartzite, and a gneiss. That immediately tells me I have increasing grade of metamorphism. Grade means higher temperature, higher pressure. Schist is low to medium, marble is low to medium, quartzite is medium, and gneiss is a high-grade metamorphic rock. Now, see where it outcrops. You have gneiss here, here. It's repeated. Just like I talk about repetition, that means it's multiple folded. That's right, and exactly. So all of it is like that. Another thing also is that will tell me it is folded is based on the presence of these arrows, these single arrows with numbers in it. Those are fold axes depending with the numbers corresponding to the dip of the fold axis. So the plunge, as we say, right? So these things are telling me I have many what is called mesoscopic fold, but the large fold is trending in this direction. It's folded like that. But I have several smaller ones which may be deformed because of local stress strain conditions. So that's one thing. Now, since you have a schist and marble and quartzite and so on, quartzite is a metamorphic sandstone which is clean, a quartz-rich sandstone. A marble is a metamorphosed limestone, clean limestone. A schist is a metamorphosed sedimentary rock, or it may be igneous rock too. A gneiss could be a high-grade igneous rock metamorphose or sedimentary rock metamorphose. But if the thing is, these are telling me certain pressure temperature conditions. A gneiss tells me that this is highly deformed. So this is telling me that this is actually deformed up to about probably 6 to 8 megapascals. Beyond that, and temperatures in excess of 750 degrees centigrade. It is telling me that this is multiple folded, which means you have several folds. It has a all writing down this, all recording it? Recording. Oh, okay. It has a macroscopic fold which has a fold axis like this, which is northeast to southwest. Superimposed on that, there are mesoscopic or smaller size folds, which probably could be about 2 kilometers or less, right? And these are trending either northwest, southeast, north-south, or sometimes north-northwest or so forth. There are different directions. Another thing is that I am seeing this here, this with the triangle. This is not dip and strike of beds. This is dip and strike of foliation, which is formed by metamorphism, right? So it tells me that the metamorphic foliation in these areas can be very steep. In some areas it is very steep, some areas it's gentle. So what happens is that the steep areas tell me that actually I have an asymmetrical fold here. Because if it is symmetrical, it'll be same. If it's asymmetrical, it'll be steep on one side, gentle on one side. So if you look here, you'll see it is very steep here. 55, 45, 65, 85, 55. Then it actually is a bit somewhat similar in this area here, but it gets gentler in some areas here. But it is gentler on this side and on this side. And then it gets a little steeper on some areas here too. So it seems that we have a steeper section here. And what I would use as evidence for a steeper section also is that the marble, which is deformed and repeated, is deformed in thin layers. So it is like probably squeeze more. When you squeeze something, it will become thinner and thinner. And generally, based on the way the diagram I draw just now, when you're looking at deformation, and if you squeeze it more and it becomes more deformed, you'll see it is squeezed off in the steeper side. And here becomes actually wider. You get my point? So you can surmise or guess that from there as well, or infer that. As far as stress strain conditions in this is concerned, this must be deformed in what you would call a fold and truss belt, because this kind of deformation is not common in these kind of areas. Another thing as well, this is in Pennsylvania. Now, you may not know this, but I'll just tell you this just a matter of fact of interest. Pennsylvania, this is in the Appalachian areas. You know, the Appalachians is in Pennsylvania on the eastern side. Then near to Cincinnati and stuff on that side. That area in the Appalachians is a fold and truss belt metamorphic terrain. I know this from knowing that. Yeah. But the thing is, This is actually a fold and thrust belt. You will only get this kind of multiple deformation from that. The fold axis for this, I suspect, is plunging. What side is it plunging? Well, from this I see many of them are plunging towards the west. I think the major one is plunging in this direction also, which is southwest. So you could say south to southwest. All right, in the southwesterly direction.
Are we across this end?
Towards here, this direction, but with this orientation, north, east, southwest orientation, just like how some of these are drawn. There are some small folds like this. These are anticlines. There may be another one somewhere, one or two of them I see somewhere. Look, one here too. Right. These are secondary folds, which are superimposed on, like, for example, let's say you could have a fold like that, but then you could have a fold like that which has secondary folds superimposed on the side, and this may have an orientation, so it may not be smooth like that. You could get something like this. You get me? Actually, these things are more common than these kind of things people draw in books and things. Anything in books is just unrealistic. Yeah. So these are secondary folds. Right, so that's one thing. From the scale, this is 1 centimeter roughly equal to, you could measure it if you'd like. It is 1 centimeter nearly to 1 kilometer. Based on the scale of this you could measure how much kilometers. So this is actually a large scale structure, because this may be more than 25 kilometers across the diagonal of the middle of the page. And then of course it must be on either side too. So this is a large scale regional structure. So you could get, even from a scale, you could talk about something also, right? And that's it really. That should be fine. Right. So then, when you discuss anything, you go to the theory to support what you have said. I hope you all record. Were you all recording?